All right, well, we're going to try number 63 now, which is kind of a combo of the sums and differences with a trig identity. So I started with the left side and I used the formula du jour. And so hopefully things will work out. So if we look at our term, it would be cosine squared x cosine squared y, which is a nice thing. Our outer term would be cosine x sine x, and then so cosine x sine x, I'm just putting the x's first, and then cosine y sine y cosine y sine y. Now our I term, this would be plus, so that's our outer term. Our I term would be the same thing but with minus sign, so cosine x sine x, and then cosine y sine y. So they're going to cancel. And then our ul term will be minus sine squared x sine squared y. So now we have cosine squared x cosine squared y minus sine squared x and sine squared y. Okay, so here's the move. It looks kind of like what we were shooting for in the first place, but you have a cosine y squared, and then you got this term here on this side over here. So the move is to bust out this this cosine squared y is equal to 1 minus sine squared y. So now you might say, well, what's up with that? Well, we want cosine squared x, so we get cosine squared x, and then we're going to get minus, and then we're going to get, in parentheses, sine squared x plus cosine squared x times sine squared y. In other words, got a minus sign, he's out in front there. Sine squared, and then this term here. And then you got to click your heels 3 times, realize that that is the Pythagorean identity. And so lo and behold, you're with cosine squared y minus sine squared, cosine squared x minus sine squared y. Anyways, that was a scrapper. For my last one, I'm going to do at 73. Hopefully everything will come out. Well, if we do the tan a plus b, we have tan x plus tan pi over 1 minus tan x tan pi. That's just using the formula per se. And hope everything works out. And then we got 2, and then it's sine, so it'll be 2 sine x cosine pi plus 2 cosine x sine pi, and that whole mess is going to equal 0. And we would pray that things work out, and I mean, there's lots going to happen. They wouldn't pick it if it didn't work out. That last one was scrappy, but this one I think should be good. Anyway, so let's do a little inventory. Tangent of pi, 0. So that's 0. So here, this whole thingy here just becomes tan x. Okay. Now cosine of pi, that's -1. So I got -2 sine x, and then the sine of pi, well, that's equal to 0. So we just have this now. So we seem to be pretty much in business. So we have sine x over cos x minus 2 sine x is equal to 0. And then what I'd do is, I mean, we know that cos x cannot equal 0. Okay, cannot equal 0 because it's in the denominator, but then I'd just bust it out and just say sine x minus 2 sine x cos x is equal to 0. With that proviso in place, it covers everything. So we have sine x times 1 minus 2 cos x, and that all equals 0. Yeah, I just checked it's from 0 to 2 pi. So here we have sine x is equal to 0, so x is equal to 0. Remember, it's from 0 to 2 pi not included, so you don't include the 2 pi. And here we get cos x is equal to 1/2, so that's going to be pi over 3 and 5 pi over 3.